Alright guys, it's pretty late, but I'm gonna do a couple of videos. Alright, so the first video, as all my stuff turns on, okay, there we go. So this particular video is going to be about the law of exponents, which is what we're doing currently in class. So I'm gonna give this a quick title. So this will be the law of exponents. And then also at the end of this video, I'm going to add in one extra skill that I'm actually introducing to you on December the 2nd, which is today now, because it's midnight. And so all we're going to do real quick in this video is just look at the law of exponents, and then I'm going to do a bunch of problems as quickly as I can. So remember that this is a recording, so you can pause, you can skip, whatever you would like to do. Use it to your discretion. Take a break, grab something to eat, come back to it. But again, really try to get this concept. All right, here we go. So I did already give you guys the law of exponents. Now, if you would have came to the session I had Tuesday night, which was yesterday, then the people that came were pretty lucky. They all left feeling like they knew what was going on, which was awesome. And there were some new laws that I went over. So I actually have covered all 6 of these with the other group, which is awesome. So make sure you come Thursday night to the help sessions. They're very quote unquote helpful. All right, so I'm going to copy down these so everybody can see them. It's not blinding with the highlighter. So again, law number 1 is called the product of powers. So when you hear product, you're basically talking about multiplication. So if I have a base raised to a power, multiply the same base, a can be anything, guys. A can be a number, it can be a letter, but it's raised to a different exponent or power. The law of exponents says to add those two powers together. Okay, let's zoom in again. Okay, the next one, and again, this one is called the product of powers. So I'm going to just put the word product. This is the product law. Then the second one we talked about so far is the quotient, which means I have a base raised to a power divided by the same base number or letter raised to a different exponent. The law says I can subtract those two. And again, this one's called the quotient. Quotient is another word for division. So just to be clear, this one has to do with multiply. And what are we multiplying? Exactly. Well, we're not multiplying the powers. No, we're doing addition. But it's the fact that the setup of those two, the base and exponents, their multiplication here. That's the product. And so you add the exponents. The word quotient is another word for division. So as you can see in this law, you see that there's a fraction or some division happening. And then you subtract the powers. All right, let's go to the next one. The next one is the power of powers. So it says, hey, if I have a base raised to an exponent or power, and then that situation here is being raised again to another exponent, you're going to multiply them, m times n. And again, this was called the power of powers. All right, so that's a new one that you will see on actually today. I'll try to find those. And then there's this other one. I'm going to throw this in there. But this one is called rational exponent. Okay, this one is a little tricky because of the way it looks. But basically, it's a power, and it's raised to a fraction, m divided by n. Okay, matter of fact, let me do this. Let me write that larger. Okay, so here we go. Big A, m over n. Is that a little bit better? So this is called the rational. Okay, so what do? Now this is going to be a little scary, but I just recommend that if it's a letter, okay, then you'll see when I apply it. But basically, I'm just going to write it. It's n, the root of n, a raised to the m. So this number in the numerator, base raised to power, goes inside of this root or radical. And then this n can be a root number. So again, this one's called the rational exponent. And listen what I say as I say this very carefully. When you see this on the star, it's actually pretty straightforward. So I don't want you to freak out about this. You'll just see how it's applied when I pull some examples out. Okay, last one. Well, 2 more. Okay, 2 more. The last one is called I keep saying last and it's two more, sorry. Another one is the negative one, right? This is the one where if I have a base raised to a negative power, basically I put 1 over and it becomes a positive power in the denominator. So again, he's not happy. And the other way to think of this, just so y'all know, is, anything that we have, we can put it over 1. So imagine for a moment that here you're negative, you don't like your position. So what are you going to do? Remember I talked about it? Come down. And because you don't like exactly where you're located or that environment, so now you turn positive when you come down to the denominator. Then the other way that I've said it to you guys is I said, think of that negative sign becoming the division bar, and 1 is a placeholder, and so it comes down here and he's positive. So whatever way you got to think about it. And this one is called the negative exponent law. So just put the word negative, because there's a negative sign on our exponent. Okay? And this one is not on the formula sheet for the star. I'm going to show it to you just because there's a weird example that I'm going to show. Any base raised to the 0 power is always equal to 1. Just accept it. It's the law. Just add this one on your sheet. A raised to the 0 equals 1. Okay, and that one's called the 0 law, the 0 exponent law. So 0. Again, anything raised to the 0 is equal to 1. Okay, so before I jump into any examples of this, hopefully you can see all of that. Okay, so how many laws are there? Let's count it out. There's 1, 2, 3, 4, 5 major ones that you will encounter for the star. And then Miss Mosley has added this extra 6th one because it's a pretty one that comes up from time to time. Not in the star, but just in algebra. Okay, so here's the deal. The first thing I'm going to do is let me just show you very quickly, like what does these things look like. So I'm going to make some up and let's do some examples. So again, if I have something like, I'm going to show with numbers as bases and then also letters as bases. So first law, if I have s to the 3rd times s to the 4th, the law says write that s base 1 time and you're doing 3 plus 4. So the answer is s raised to the 7th power. Easy, straightforward. Again, that is law number 1. Keep in mind they have to have the same base, just different powers we add. Okay? Now what happens if it's not about it being a letter? What if it's a number? So if I had 3 to the 4th power times 3 to the 6th power, the answer is 3, the same base, and then 4 plus 6 is 10. So it's 3 to the 10th power. So just to be clear, okay, it's really important for you to understand that that A that's in the law of exponents, it can be a letter or it can be even numbers, because it can be anything, all right? But you're just adding. That's pretty straightforward. All right, next one. What about the quotient? So again, this was law number 1 examples. Let's go to number 2. So the quotient one says, hey, what if I have I'm going to use the same letters, s to the 6th divided by s to the 2nd. Okay, so this we're going to do subtraction. So we're going to do s6 minus 2 equals s to the positive 4. And I'll spare you guys, but I can expand this visually and show you that as well. But we'll just stick with the formulas. The next one again, what if our base is a number? So what if I had something like 5 to the 8th power divided by 5 to the 3rd power? So I would write 5 one time and 8 minus 3, it's 5 raised to the 5th power. Okay, now of course if they have numbers as the basis, well, you can evaluate this in the calculator. 5 raised to the 5th power is some very large number in the thousands, but if it's a letter, just leave it like it is. So again, this is law number 1, example, law number 2. Okay, let's look at law number 3, which is the power of powers. So what happens if I have s raised to the 7th power, and then it's being raised again to the 2nd power? So you're going to do what? Multiply. So you're going to say s 7 times 2 is s to the 14th power. What happens if this was a number? Okay, so what if I had something like 6 raised to the 2nd power raised to the 10th power? You're going to multiply. So you're going to do 6 is my base, and then do 2 times 10. So the answer is 6 raised to the 20th power. And then you could just put that answer in the calculator if you needed to. All right, so again, this was law number 3. Next one, what happens with rational? Okay, so that one I'm going to come back to in a second, but I'm going to just show one really quick example. I'm going to come back to it though, like in more detail in the examples. So what happens if I have something like 5 raised to the, I don't know, let's say 1/3. So here's what the rational law says. The rational law says, hey, A, whatever your base is, raise it to the m, put it inside of here, and then the number that's in the denominator is the root number. So guess what this becomes, guys? This becomes 3 is my root number, and it's 5 raised to the 1 power, which is just 5. And you could put this in the calculator and get an answer. All right, what happens if it's a letter? So what if I had s raised to the 2/3? So again, the root number is 3 again. And inside of here, I'm going to put s squared. And I promise you, when you see what they do on the star, it's not this nasty, so it's okay. So this is, again, the one that was the rational. Again, don't give this one too much energy. Okay, let's move to the next one. So what happens when we have the negative power law? So again, if I have, I don't know, s raised to the -4, okay, not happy where he is. You can act like this is over 1. He's just going to move down, and then he'll be happy. So here's what happens. It becomes 1/s to the +4. Okay, and I have talked about that what happens when you have multiple variables, right? You move their positions. We'll see that. So 1/s to the 4th, and then the next one, what if I have, I'll move it right here side by side. What if I had a number like 6 raised to the -5? So this would become 1/6 to the +5th power. You can plug that in the calculator. It's a very small decimal. Okay, again, this was the negative law of exponents. Okay, next one, last one. And you just have to accept this one. This is the 0 power. So anything, so if I had s raised to the 0, it equals 1. If I had 10, 100, doesn't matter, raised to the 0 power, still 1. That's it. I accept it. And this again was the last one. So just to be clear, okay, just to be very clear, on the star, what I've seen, and you're going to see some examples, they love to use this one, they love to use this one, they love to use this one, they love to use this one. You may not see this one very often, and maybe not that one, okay? But I just want you to know about them. But these are the major 4 I want you to focus on. All right, so now let's get into some examples, and then hopefully this will be a short video. Okay, let me get to a fresh sheet of paper. So, you know, we've done some of these already in class. So I've showed this one. I've showed this one. You can watch the recordings. This one was H. Okay. I'm going to go ahead and start at this one just to redo this one again, but I've talked about this one quite a bit. Watch the recording. So I'm going to write this one down as parentheses 8x raised to the 3rd, y to the -2, and then in this one -2, x to the -5, y to the +6, close. Okay, so the first thing I look at when I look at this is that I know I have multiplication. So when I have those parentheses, we're doing some multiply, plus everybody's right next to each other. So let's just do everything in grouping. And that's what I told you in class, is that the key points for this skill were, number 1, group our like bases. So bases with the same letters and even numbers I showed you, you can put them together. Group like bases, put them together, group them together. And then what do? Identify what mathematical operation is happening to that group. You know, is multiplication happening to this group? Is division happening? And then apply the law of exponent using our formula sheet. So here we go. So the first thing I'm going to tell myself is 8 times -2. So real quick, here and here, I'm going to multiply those two numbers together. It'll be -16. So 8 times -2, -16. Bam, done with that. Then I'm going to come in and I'm going to group my x's together. So we have x to the third being multiplied. This is all multiplication. X to the negative 5. So if I have x to the third times x to the negative 5, grab my formula sheet, and basically it says if I have the same base with these different powers, I can write that base one time, and then I do what? Addition. So again, same bases, different powers, add them together, leave that base the same. So this becomes x 3 plus negative 5, which is x to the negative 2. Again, that's a negative 5. Okay, then the cool thing is you look at this and this is not proper. So you go back to the formula sheet and you say, oh yeah, we have this one called the negative of powers, which says if I have a base raised to a negative exponent, do 1 over and then make it positive in the denominator. So this right here becomes 1 divided by x raised to the second. So I want to understand that the x is in the denominator and then negative 16, like that's over 1. See, he's in the numerator. Okay, let's go to the next one. Now let's group together our y's. So for the y's, I have y to the negative 2 times y to the 6. And I'm going to put those two together. And then what will I do? I'm adding. So y to the negative 2 times y to the 6 is y negative 2 plus 6. Okay, so again, then you apply the rule of integers. So don't tell me like, oh, Miss Rosie, but I subtracted, you said addition. No, just put your plus, apply the rule of integers. So this becomes y to the positive 4. Okay, and so just to be clear, when you have a variable raised to a positive exponent, it's in the numerator. Okay, so putting it all together, here's the answer. The answer to this is, if this is what they gave me on the test, we say it's equal to negative 16. Y to the 4th is in the numerator, so we put times y to the 4th over, and then the x squared is at the bottom. Okay, so that's the answer. Next one. Okay, so again, we've done this one, we did this one. All right, so now we keep going, and let's try one of these two real quick. So I'm going to probably do this one right here. So now, you're going to be practicing this today more in Nearpod. So we have 7 x to the negative 2, y raised to the second times 2x to the 8th, y, all divided by 4x to the 5, and then y to the negative 3 is in the denominator. Okay, same concept. Ready? Group them together, identify the operations, apply the law of exponents. So the first thing I'm going to do is to all of these actual numbers or constants, these coefficients, I'm going to say, hey, what's going on with all this math here? 7 times 2, and then divided by 4. So I know that 7 times 2 is 14. And again over 4, this becomes 14 divided by 4. So I just multiply the two coefficients and then leave the 4. I can reduce this. They're both divisible by 2. So everybody should understand, divide by 2, divide by 2. This is 7 over 2. Great. So now I know I have a 7 over 2 in the front of my answer. Next thing, let's group together our x's. So I'm going to go ahead and say I got x to the negative 2, x to the 8th, and then on the bottom, x to the 5. Okay, so real quick, doing my scratch work, we got x to the negative 2 times x to the 8th, all divided by x to the 5. So ignoring the denominator for just a second, the law, according to our formula sheet, says that if we have, the same base being multiplied with these different powers, we do addition. So that means I'm going to do x and then negative 2 plus 8. We're going to finish evaluating this, but we still have that x over to the 5th on the denominator. So this becomes x to the 6th power divided by x to the 5th power. I just subtracted those. Okay, now we're not done simplifying, because now we look at it after we applied the product one, we have a quotient now. And what do I do to these? Same base, different powers, subtraction. So I have x 6 minus 5 is x to the 1 power, okay? X to the 1 power. And where does he go? Well, it's positive, so guess where it goes, guys? In the numerator. So I'm going to basically circle this in green, and I'm telling you he's going to go right here. I don't have to write the 1. Okay, let's do the y's, and this problem's done. So now for our y, grouping it together, we have y to the second times a y to the 1 up there, and on the bottom, y to the negative 3. Okay, so if I group into my scratch work, I have y to the second times y, I'm going to just show the 1, divided by y to the negative 3. Now this one I'm going to show 2 ways. So first, again, this is the product. So this is y2 plus 1 over, and I still have y to the negative 3 in the denominator. So then I come over here, and I got y to the third. 2 plus 1 is 3. And then I still have this y to the negative 3. So now what can I apply? The quotient law. But I told you guys the other trick I showed you is if you're not happy where you are, move your environment, move your location, and be happy. Create this positive life that you want, right? So we're going to move this guy up. I'm showing this 2 ways. So I'm telling you this is the same as having, look guys, there's a y to the third. And then when you bring him up, there's multiply y to the positive 3. He's happy being up at the top in the numerator. So do you see you would add those 2, and this is y to the 6. Okay, so boom, y to the 6, and it's positive, so it's going to be in the numerator. Now the other way I'm going to show you is applying the quotient law, which again, this right here is like putting y, I do subtraction. So I have 3 minus, this down here is a negative 3, minus minus becomes plus plus, it's still y to the 6th. So whichever way makes sense to you. Now I'm going to circle this guy in red. And so again, he's in the numerator. Problem is done. So basically you would say all of this stuff, which looks really scary, is simplified now to 7x y to the 6 divided by 2. All right, let's keep going. Most of these videos are going to be like 25 to 30 minutes. I'm just telling you right now. Okay, so let's keep going. So now next example, I'm taking care of this one. You know, and again, I can do some that are just so similar, you know, but I want to change it up. So don't let these freak you out. We did some of these in class. I think we've done this one. So I know I'm going to go ahead. Let me show you that one because I haven't done this one. I've done this one, I think. I think this is the one is, remember, 3 times 3 is 9, and then over 2. So see, the answer to this one is B. So if you need to pause the video and you want to work this out, I'm not going to go over this one because we've done it already, but it was 9x to the 4 over, and the trick was 9 is the 3 times 3, and then the 2. It's the only answer choice that had 9 over 2. Okay, I have not done this one. Here we go. So now again, if I have 3 p raised to the negative 4 divided by 3 to the 4, q to the 3, r to the 4. This one's kind of long in the denominator, so extend this, and then 2, negative 1 for p, r to the 4. Okay, there. That's the problem. All right, so first things first, we're back to the grouping. I'm going to move really quick now. So I'm going to highlight all the coefficients, group that together for the math, and so that tells me I'm going to have a 3 in the numerator over 3 times 2, which this becomes 3 over 6, which reduces to 1/2. I divided by 3 to the bottom and the top. So far, this math here, it's a 1/2, and I'm going to just draw this out a little longer. All right, now let's go do our p's. So I have p to the negative 4, p to the 4 here, and then times down here, there's a p to the negative 1. So if I start grouping it together, scratch work, p to the negative 4 over times p to the negative 1. Okay, so again, going to show it 2 ways. So I'm going to leave that p to the negative 4 alone because nobody is up there with him. So just transfer him over. Don't move him yet. But on the bottom, in the denominator, I'm going to apply the product of powers. So I got to do p 4 plus negative 1. So leave that p to the negative 4, and then on the bottom is p to the third. Okay? So again, I'm showing this two ways. So you can go ahead and do the quotient law, and I'll just use one color in red this way. So that means I could do same base, we're going to do p negative 4 minus, there's a positive 3. So this becomes what, guys? P raised to the, what's negative 4 minus 3? Grab your calculator. It's negative 7. P to the negative 7. Okay? And then you would tell yourself, well, Miss Mosley said, because we have that formula sheet. Where's that one? I thought I have it. Never mind. Yeah, I have the formula sheet. I'll just do the one by hand. I wanted to show you the other one, but that when we have a negative power, put 1 over and then base raised to that to a positive. So this is 1 over p to the positive 7. Okay? So again, this is the formula way, applying the quotient, do the subtraction, it's negative 7, put them in the denominator. Now the other way I showed it is, you know, this negative 4 is not happy where he is, move his location or environment, so he's going to come down to the denominator, and so what happens to this one, put another color, is if he came down here, we still have to show we have a numerator. So the placeholder is 1 over p to the third, and then because that p to the 4 is coming down here, you see this is still multiplication. This is still the product of power, so you have to add, and this is 1 over p to the 7. I just did 3 plus 4. Same answer. Okay, so if you like doing it with the actual math, or if you like moving your negative exponents to different locations and then looking at it, you're going to get the same answer. So this is in the denominator. It's very clear that that p to the 7 should be down here. All right, let's do R, Q, and our R's. So Q, let's put him in this color. Notice that there is no Q in the numerator. So what does that mean? Like, oh, there's no Q up here. What do I do? I'm freaking out. No, just put a 1. So when you get ready to put this together, remember, this is happening in the denominator. So you got to put a placeholder. So for the scratch work, I'm going to put 1 over Q to the third times Q to the second. Because where are those Q's? They're just in the denominator. So there's a denominator always, and there's a numerator. So you got to put a 1. So now right here, we're just going to do addition. So we're going to do 1 over, and this is Q to the 5th power. 3 plus 2 is 5. And so what does that mean? Q is in the denominator to the 5th power. So I'm going to come over here and put Q to the 5 at the bottom. You don't need to write the 1 again. Okay? It's okay. All right, last one. Let's do the R's. And for the R's, I don't know, colors. So I'm just going to circle. So, sorry. So I have R to the 4th, still in the denominator, R to the 4th down here. There's no R's up here. So when I get ready to group this together, it's going to be 1 over. Let me see something real quick. Oh, it's still going. I thought that it stopped, guys. Sorry. So it's going to be 1 over. I'll show you where I got. So 1 over R to the 4 and R to the 4 at the bottom. And you're going to add times R to the 4 is 1 over R to the 8th, because I did 4 plus 4 is 8. So again, the R is in the denominator. So it's just going to be a fun problem because everybody's in the denominator, but you still had that 1 there from reducing. So this is the final answer. The final answer is 1 over, I'll write it neater, equals 1 divided by 2 times p to the 7, q to the 5, r to the 8th. Okay, that's the final answer. Oops, sorry. And then when you look on the worksheet for the answer choices, the one we would circle is going to be this one right here. P to the 7, q to the 5, r to the 8. Yep. P to the 7, q to the 5, r to the 8. Yeah, the answer is A. Okay? Be careful because, again, they have some that are pretty close. P to the 7. Oh, something happened there. Okay, let's do, again, I think I even did this one. Yeah, I did this one too because in class, remember, everybody finished really fast. It was 3 times 3 over 2, so it was a 9 over 2. The answer for this one is D. So if you want to pause the video and work this one, you can. But the one I have not done is I'm going to do this one, I think. Or you know what? Okay, let's do this. I'm probably going to do now, I'm going to do this one. I think y'all get the point, but I'm going to do this one super quick. Number 6, and then that's it. But if you want to pause the video, there's some other examples right here. You can try this one on your own, number 4. Try this one, see what you get, number 5. Maybe I could give you the answers real quick. Let me think. The answer to this one, Q to the third, and the bottom is Q to the third, 3 and 3. There will be no Q in our answer. I want to say very quickly, just at glance, I think the answer for this one, number 4, is this guy. See if you get D, and then talk to me about it. Number 5, very quickly. Again, these are just extra examples. I'm going to do number 6, and then I'm going to switch over to something else. Okay, for this one, I can tell you the answer is C. Work it out, see if you get C. All right. And don't cheat. Don't just be like, oh, okay, Miss Mosby, it's just 4 times 4, blah, blah, blah. No, get some work on the R, the P, and the Q. All right, so let's do this one, and then that's it for those. I'm also going to pull up some star questions so you can see how they ask the question. Okay, really quick. So this one is x to the 4, y to the 4, z to the 3 over. I put slashes through here so it doesn't look like a 2. That's the letter z. And then 4x to the 4, z squared is 2. And then z to the 4. Extend this. Okay. I know I'm a little over, but oh well. Let's go. So now, this one, we're going to group together. I'm going to use some colors. Let's circle all of our x's. Then I'm going to write them together in red. But again, I already know that there's a 1 over, and then y'all see this 4 times 2 is 8. So far, I know I have 1 over 8. Okay, you don't see a number up there, so just put a 1, because there is a numerator, and the denominator is 4 times 2 is 8. Okay, so real quick, the scratch work, I have x to the 4 over x to the 4 times x squared. So this becomes x to the 4 over, add those together, x to the 6. And then the quotient law says x, 4 minus 6, x to the negative 2, 1 over x squared. Did that super quick, just focus, focus. So this is in the denominator, x squared. Now let's do the y's. So the y's in blue, I have y to the 4th there, and y to the 4th there. Now watch this one real quick, guys, okay? In blue. So I have y to the 4th over y to the 4th. Well, when you do the quotient law, this is y to 4 minus 4, which is y to the 0. And remember I told you that there's one called the 0 law, that anything raised to the 0 power is a 1. Okay? So I'm just telling you that this is a 1. So between you and me, don't write anything in your final answer, because there's just a 1. Don't even write it. You're good. You're done. There's just no y's. Okay? That's the best way I can say it. So you don't have to do anything here. Last part, the z's are going to be in green, and their location. Kind of running out of room here, so I'm going to move this way. So I have z to the 3rd over z squared times, at the bottom in the denominator, z to the 4th. So leave this z to the 3 alone, over, and then I know that I'm going to add the 4 plus 2, so that's z to the 6th down at the bottom, and then applying the quotient, I'm going to get z 3 minus 6, which is what, guys? Z to the negative 3. And then again, I don't like this. It becomes 1 over. I'll just put it right here. 1 over z to the 3rd. So the z is in the denominator to the 3rd power. Again, I did 3 minus 6, which was negative 3, and then I applied the negative law. So the z to the 3 is down here at the bottom. There's a 1 in the numerator. That's my final answer. And so if we look at our answer choices, it is A. All right, so I hope everybody's good on those. And again, just giving you an opportunity one more time that you could try number 4 on your own, pause the video, you could do number 5, see if you got it right. That was number 3, number 2, we'll just show those. Pause the video if you want to do more practice and understand this. Remember, there are 2 questions on the star like this. All right, now the last thing real quick for this video is what do questions look like from the star test? And here they are. So we did this tonight, the group that came. So what I want you to do is work this one out on your own. Don't worry about that it says exit ticket. Work this one out, pause the video, get this one. See if you get B. This is a star question. Okay? Not going to work that one out. Pause the video. And then right here, this one I am going to do for you is this is another star question. Which expression is equivalent? Here it is. It says for all values of x and y. Basically, just say, hey, apply the law of exponents. The answer should be h. So I'm going to work this one out super quick. And the reason why I want to do this one is because it's a law that you haven't seen, which is this one, the power of powers. Real quick, this one. I have a base raised to a power, and then it's raised to another power. I have to do multiplication. So if I write this one down, it's x and then y to the negative 6 raised to the second. Okay, so the first thing you need to realize is that, yes, you have an x, you have a y. This y is raised to the negative 6. So the one that makes the most sense to me very quickly is, oh, look, from the formula sheet, Ms. Mosley said that for the power one, it's a base raised to a power raised to another power. I need to multiply, okay, right? So when I look at this, just for the y for a second, I'm going to say, hey, I have y to the 6 raised to the negative 2. I need to multiply those together. Can y'all see that? So this becomes y to the negative 12. And then this is not proper, right? So this becomes 1 over y to the 12. Okay? Now, I'm going to show y'all this. This was from the sheet. So everybody should understand how I got that. Pause it or replay it again. Okay, now check this out. From this sheet here, they actually have the power one. They have it here. And then they also show, well, what happens if you have 2 bases raised to the same power? 2 different bases. This could be a number. This could be a letter. This could be 2 letters. Doesn't matter. Each individual base gets raised to that same power. Each individual base gets raised to the same power. Here's an example. 3 times 4 is 3 to the second, 4 to the second. All right? You can also apply it to letters. So when I look at this, you see how you have 2 different bases, guys? This is the same as x gets raised to the second power, because remember there's a 1 here, and 1 times 2 is 2. So we're going to do x to the 1 times 2 is just, again, x to the 2. And I'm going to redo this one again for you so you can see it. So this base, multiply, gets raised to the second, and then this guy, whatever the variable is, multiply. So this was y to the negative 6, and then I times by 2, y to the negative 12, right? But when you put this together, remember this wasn't proper. So basically you have this in the numerator, the y's are in the denominator. So the final answer to this is x squared over y to the 12. Okay, just replay it again. Now, this is the proper mathematical way to do this. However, as you can see, they don't have it in fraction form. So this is the answer you would circle, x squared y to the negative 12. But the right way to really write it, because you don't like negative exponents, is that way. But based off of the star, circle h. Okay, that's that. Now again, I'm going to show one more, this one. The answer is 43, but I'm going to show you why. So for this next one, it says, ready? The expression x to the 22 times x to the 7 raised to the 3rd is equivalent, is equal to x to the p. What is the value of p? So notice for this one, guys, this is an open response. So we're going to do open parentheses, x to the 22, and then x raised to the 7 raised to the third. So for this one, what you'll notice is don't do anything to the x to the 22. Don't do anything for x to the 22. So just write him like he is. But then for this one, you see, you're going to apply the one with the power law. The one that says, if I have a base raised to a power raised to another power, multiply the two powers or exponents. So basically this becomes x7 times 3. And again, now I have x to the 22. And then right here, this is 21. X raised to the 21. I'm just leaving the parentheses. And then again, we have the same base, different powers. What do? We do law number 1. We're going to add those two together. So the final answer is 21 plus 22 is 43. Y'all see that? And remember, in the problem it said that this expression is equal to x to the p, shown in the problem. The expression, this, is equal to this. So if I set this equal to x to the p power, and I'm trying to figure out p, I did my math, that means that the p, sorry this is written so poorly, this p is equal to 43. So forget about the x's, they just want the p value, it's this exponent 43. So the answer is p equals 43. All right, that's that. And I'm going to show one more, and then that's it for notes. Okay, the last one, this also was on the star. I'm just going to show it. Oh, I'm out of room. Okay, it said, which expression is equivalent, and they wrote this, 144, k to the second, r to the 14th, and it's closed, and they're raising it. Look, guys, here's one of those rational laws. It's raised to the 1/2, 1/2, okay? And they wanted to know, basically, break this down. So if I go back to the formula sheet, what I would do, honestly, is even though, don't freak out that this is a fraction and be like, oh my God, I need to use this one. What do I do? Blah, blah, blah. Why don't you focus on the fact that here's a base raised to a power. It's in a parentheses. It's raised to this n. So you see how you could just multiply? So watch what I do real quick, guys. So the first thing I'm going to notice is, well, again, my bases can be numbers and letters. Doesn't matter, okay? But everybody gets raised to whoever's out here. So let's do 144 raised to the half power. Please plug that into your calculator so you don't freak out on me. But this is the square root of 144. I'm just going to tell you the answer is 12. So do 144 raised to the 0.5 or 1/2. The answer to this, guys, is 12. Do it in the calculator. Okay, now I'm going to go focus on the variables. So if I have k raised to this power and it's being raised to here, what do? I multiply. So k squared times 1/2, half of 2 is 1. So it's just k to the 1 power. That's it. And then the r is raised to the 14th, but what is it doing? Being raised out here. So I just want to be clear, we're actually, don't think that it's the rational one. It's actually more this guy. That if you have a exponent raised to another exponent, multiply. So now if I have r to the 14th, right, and it's being raised to the 1/2, we're just timesing this by half, and I know half of 14 is 7. So putting this all together, here's the answer. The answer is 12, k, don't put the 1, r to the 7, because all of these exponents are positive. It's all in the numerator. And so if you go to the answer choices, it is F. Okay, so that's the end of this video, and I hope you understand the law of exponents better. Okay, and for the sake of time, I'm just going to stop it here. But I will tell you, there's one other skill that I'll introduce in another video, but you'll see it in class. All right, guys, talk to you later.